This video is on oxidation numbers, what they are, and how to assign them. So oxidation numbers, I'm going to look at number 2 here first, are hypothetical charges assigned to an atom using a set of rules. Oxidation numbers, finding them, the purpose of this is to see what is being oxidized versus what is being reduced. Because that's what's happening in our redox reactions, and you always need to have one with the other because of this transfer of electrons. So number 1, which actually is in the rules also, is an actual charge of an atom if it's a monatomic ion is its oxidation number. For example, sodium in a compound, if it's sodium plus 1, its oxidation number is plus 1. All right, so how do we assign oxidation numbers? How do we figure these out? So for an atom in its elemental form, the oxidation number is always 0. So if I have like chlorine, let's say, chlorine in its elemental form would be a gas and it'd be Cl2 because it's diatomic. Its oxidation number would be 0. For any monatomic ion, the oxidation number equals the charge. And nonmetals usually have negative oxidation numbers, although they can sometimes be positive. Okay, so oxygen is almost always -2 in ionic and molecular compounds. The exception is when you have a peroxide, which is when you have O2, like in a compound. So not O2 by itself, but like H2O2. Hydrogen can be +1 or -1. It's +1 when it's bonded to nonmetals. And the way I remember this is nonmetals have a negative charge, so hydrogen would have to be positive to balance it out. It's a -1 though when it's bonded to metals, because metals are positives, are cations, so then your hydrogen will act like an anion to balance that out. Fluorine is -1 in all compounds, and other halogens are typically -1 in most binary compounds, except when they're with oxygen. Then they'll end up being positive. Okay, so let's go through some examples. All right, so this says determine the oxidation number of nitrogen. So we're looking at the nitrogen in all these. This first one, nitrogen N2, I have to assume it's in its elemental state. So its oxidation number is 0. All right, so let's look at the next one, KNO3. All right, so K is going to be a +1, right? If I go back to here, any monatomic ion, the oxidation number equals the charge. So that's what K is. So this K is a +1. O is a -2. And I have 3 of those. So together, all of them are a -6. So I got to think about this. I have +1, I have my nitrogen, and I have a -6. And they're going to add up to the charge of the whole thing, which is 0. So what would my nitrogen have to be? Well, my nitrogen would then have to be a +5. So we're just kind of solving the puzzle, figuring it out, what's missing. All right, so the next one, N2O4. So in N2O4, I have, hold on, oxygen, which is a -2, and I have 4 of them. So times 4 would be a -8. All right, so my overall charge is 0. So I have 2 N's. So 2 times whatever N's charge is. Oh, come on, pen. Okay, plus a -8 is going to add up to 0. So what would my N have to be? Well, my N would have to be a +4, right? 4 times 2 would be a +8, plus a -8 would add up to 0. So then the last one here, my O is -2, and I have 2 of them, so that becomes a -4. Now I have 1 nitrogen, so whatever my nitrogen's charge is, plus -4 is going to add up to, in this case, a -1. Because we have a polyatomic ion here. So what does N have to be in this case? It's going to have to be a +3, because +3 plus a -4 would add up to -1. So that is how you assign oxidation numbers. Remember to go back and refer to the rules if you're getting stuck.